So the binomial theorem basically is a shortcut for allowing us to take a binomial, which means we have two terms in parentheses, and I'm going to raise it to some power, okay? I'm not going to just give you that right away, though. We're going to kind of figure it out together, because then you'll appreciate the formula even more so, okay? So we're going to kind of go through these first 5, because we've done this before. Like, we know how to expand these, so let's go ahead and do it. So x plus y to the 0 power, that's an easy one. What is x plus y to the 0 power? 1. Anything to the 0 power is just 1, right?
Yeah.
X plus y to the first power would just be x plus y. X plus y squared, that's like, x plus y times x plus y. My least favorite thing is when I see people write this, x squared plus y squared. That just like makes me hurt. Don't do that, okay? There is a middle term in between. What is that middle term that's in between those two things? 2xy. So I've got x squared plus 2xy plus y squared. Okay. You'll have room to do one of these. I will just do the other one, so you don't have to do that on your paper because it's not quite enough space. Unless you want to do it like on the back side. There's plenty of space on this part here. But I'm going to take this whole thing now and multiply it by x plus y to get x plus y to the third power, right? So, one step at a time, x times x squared gives me x to the third power. X times 2xy will give me what? 2x squared y. Very good. And then x times y squared gives me just xy squared. And I always like to write my x first, or whatever the, alphabet says for what letters I've given. And I'm going to multiply y with everything. So y times x squared gives me x squared y. Y times 2xy gives me 2xy squared. And lastly, y times y squared gives me y to the third. But I can combine some of these things together, right? What things can I combine? 2x squared y and x squared y. And xy squared, 2xy squared, okay? Has to have the same exponent, same variable. Don't get tricked up with that. But then when I add these together, my final answer would be x cubed. I'm going to write it just next to this. X cubed plus 3x squared y plus xy squared plus
Krista Becker, please
y
come
cubed.
to the office.
All right, you guys won't have space for this. I'm going to do one more time. You guys follow along, make sure I don't make any mistakes. Sound good? If you want to write it down, just write it somewhere else, maybe on your note sheet, because you just won't have space right there unless you write really small, okay? So I'm going to take this whole thing now, and I'm going to multiply it again by x plus y to find out what is x plus y to the fourth power, okay? So x times x cubed gives me x to the fourth. X times 3x squared y, 3x to the third y, plus 3x squared y squared plus x y cubed. Good so far? Okay, then I'm going to multiply the y with each term. So I've got x cubed y plus 3x squared y squared plus 3x y to the third plus y to the fourth. We good so far? Any mistakes? Okay, so now I can combine my like terms, right? My like terms that I can combine are 3x cubed y with my x cubed y. I can combine my 3x squared y squareds together, and I can combine my xy cubed together. So our final answer for this would be, and this is what I do want you to write down on your paper, is x to the fourth plus, let's see, that's 4x cubed y plus 6x squared y squared plus 4xy cubed plus y to the fourth. That is x plus y to the fourth power. And then I don't really want to try and do another one, okay? So I'm just going to tell you what the answer is, and then we're going to talk about maybe how could I figure out this answer without doing really any sort of math and just kind of figuring out a pattern, okay? So the answer for x plus y to the fifth power would be x to the fifth power plus, what was my number? 5x to the fourth y plus 10x to the third y squared plus 10x to the second y cubed plus 5x y to the fourth plus y to the fifth. That is your x plus y to the fifth power. Okay, so just spend a minute or two kind of looking at these 5 different binomials expanded with the answers that you got. What kind of pattern are you seeing? Don't shout it out. Think about it. Maybe talk to your neighbor about it quietly, and then we'll talk about kind of what's happening. Math is so cool. You're right. Okay?
I was just joking. I don't actually think
That's rude. So the Pascal's triangle, if you're not familiar with what the Pascal's triangle is, it's taking and putting ones kind of down on the borders of a triangle, basically. And what happens is underneath, you add the numbers together. So like, for example, this 1 plus 1 gives me 2, right? This 1 plus 2 gives me 3. This 1 plus 3 gives me 4. And that works throughout the entire triangle. I could look in the middle here. 6 plus 4 gives me 10. Okay? You probably did at some point. Some guy named Pascal a very, very long time ago came up with this triangle. Okay? And it is used for things like this binomial expansion. Don't ask me exactly how or why it works, but it does work. So if we're finding, let's say, the fifth expansion, we would look in the fifth row of Pascal's triangle to find the coefficients of each term in our expansion. That's where the 1, 5, 10, 10, 5, 1 come from. Okay, if I looked back at my fourth expansion here was x to the fourth plus 4x cubed y, 6, and then 4, and then 1, right? Well, that's where my coefficients come from, 1, 4, 6, 4, 1. That's the fourth row. Okay, the third row, if I go back and look at my third expansion, my coefficients of my third expansion were 1, 3, 3, 1. 1, 3, 3, 1, my third row. Kind of cool, right? So there is another way that I'll show you here in a minute, but if you grab out your gold sheet, on the back of your gold sheet is Pascal's triangle up to 7, okay? Up to 7 is Pascal's triangle, and you can use this on your quiz and your test to figure out your coefficients of your binomial expansions, okay? And it even on the left or the right hand side of your sheet there, it even has like x plus y to the 0, x plus y to the first, so it shows you which one you're doing. You're doing the first row, second row, third row, or the first degree, second degree, third degree of that binomial expansion, okay? So here's what the actual binomial theorem is in mathy words, okay? Which we need to talk about one other thing real quick because we didn't talk about it last time. Last class when we were talking about combinations, so like NCR, another way of writing it on your notes is the C parentheses N comma R. That's one other way of writing it. There's also the formula, which is N factorial over N minus R factorial times R factorial, right? There's one other way of writing it as n over r. When you see this notation, you usually read it as like n choose r. I also say it like that for this here, n choose r here, but this is another way of writing it. So if you look in this binomial theorem, we're using that combination multiple times, and we're going to talk about where those numbers come from, okay? So, again, for those of us going into STEM-related fields, we're going to have to get used to being able to kind of digress what this kind of information is saying. So I'm going to kind of walk through it, and then we will look at an example, okay? So this is saying if I have any binomial x plus y raised to some power n, it could be any number, my answer every single time will be the first term raised to the nth power, and then it'll be the first term raised to the n minus 1 power. The next term would be the first term raised to the n minus 2. So you're just subtracting 1 each time from your exponent, right? Until you can't anymore. Then your second term here, you're doing the same thing, but you're starting with the 0 technically, because it's not there. And then you're going to the first power, to the second power, to the third power, all the way up until you're done with however many numbers you have. The coefficient part is either using your Pascal's triangle or plugging it in the calculator and using NCR and finding the combination of whatever your exponent is and 1. Technically, it's not written here, but before the first term, there would be an n choose 0, which anything choose 0, how many ways can you choose 0 things? There's only one way of choosing 0 things. You just don't take anything, right? So it's always going to be 1. But then it goes up again all the way until you get to your highest number of your exponent, okay? So this isn't written out individually. This formula here is our summation of all of the terms, which is exactly the same thing that is written above, but it's just written with only one term instead. So that is not on your gold sheet, but the expanded version is. So if you would like to write the shortened version on there, you can. It's just up to you, whatever makes more sense, okay? Another thing that you also might want to add on your gold sheet is this notation right here, remembering that n over r, this thing right here, is the same thing as a combination. So maybe just add that, or just put a little arrow and say combination or something next to it so that you know what that is. All right, let's go ahead and look at this example. So write the binomial expansion of x plus y. Let's change that 9. Let's just do 5 again, okay? So we're going to use the formula and find the binomial expansion of this binomial to the 5th power, okay? So using this formula above, my n is the exponent, which is 5. Okay, in this formula, this r value is going to change every single time, every single term, up until you get to 5. Okay, so r is starting at 0, but it's going up to 5. So let's write this out. What is this going to look like? Well, in terms of the summation formula, I've got the summation from r equals 0 to 5 of 5, choose r, because that's going to change each time, times x to the n minus r, or 5 minus r in this case, times y to the r. Okay, this x is always just the first term in your binomial. It might not be x, maybe it is z squared, okay? Same thing for your y. Your y is not always going to be y. It's going to be your second term in your binomial. Maybe it's a fraction. Maybe it has a negative, okay? Whatever your term is in your binomial is what replaces for that x and for that y. Now, this first example, I just kept it as x's and y's for the simplicity of it, but the next example, we will have to change it up a little bit. So let's go ahead and enter all this information in now. So I'm going to start at 0. So I'm going to do 5, choose 0. of x to the 5 minus 0. I'm going to write out everything for this first one so you see where all these numbers are coming from. And then I think after you do one or two of them, you'll kind of see and start to see the pattern. So you won't have to write it this formal every single time, and that's fine, okay? I've also got y to the 0 power. Now I'm going to go up to 1. So 5, choose 1 of x to the 5 minus 1 times y to the first power. Next is 5, choose 2 of x to the 5 minus 2 times y squared. Plus 5, choose 3 of x to the 5 minus 3 times y to the third power. We following so far where I'm getting all these numbers from? Okay, then I've got 5, choose 4 of x to the 5 minus 4 and y to the fourth. And then lastly, 5, choose 5 of x to the 5 minus 5 times y to the fifth power. Okay, now let's simplify all these things. Okay, I can simplify all of these 5, choose 0, 5, choose 1, 5, choose 2, 5, choose 3, 5, choose 4, 5, choose 5, either by using your calculator and typing in 5, choose 0, 5, choose 1, 5, choose 2. Or where else could we look? Pascal's triangle. We could look at the fifth row of the Pascal's triangle and get the coefficients that way. Okay, I do want you to try really quick though, just so we make sure we remember how to use our calculator. Try at least the first, second, and third, plugging those in as NCR or 5C0, 5C2, 5C1 to check those out. Again, all of my x values are decreasing by one exponent each time to 0. My y values are increasing, starting at 0, going up 1, 2, 3, 4, 5.
Is that how it is for everything?
That's what it'll be every single time. Now, your number that you're starting with might be different. So, like, you might start with x to the 10th power, or whatever your x value is to the 10th power. But then, yes, your y value would start at 0 and go up to 10. X starts at 10, goes down to 0. Okay? Which is why, like, this fancy, like, formula looks really complicated, but really all that's happening is it's going down by 1 or increasing by 1 each time. Again, I think let's change this to not 5. Let's do, no, let's do 4. Let's do 4. It'll be good practice. Okay, so this time I don't have x's and y's. I have a, so this is my first term. And I have negative b over 2 as my second term. This whole thing right here, negative b over 2 is my second term. My first term is just a. So in terms of the formula, x is a and y is negative b over 2. Okay? Otherwise from here, we just start plugging it in. So I'm going to start my highest exponent. My n value is 4. So I'm going to have 4, choose 0. Of a to the 4th power. And then I'll have, make sure you're putting these negatives in parentheses, or if it's like, 3b or something like that, make sure the whole thing is in parentheses. This whole thing, negative b over 2, is raised to what power? The 0 power. And again, you don't have to write that every single time. I'm just showing it so it doesn't just like disappear randomly. It did come from somewhere, okay? All right, then I'm going to do 4, choose 1 of a to the 3rd power. And negative b over 2 goes to the first power. Okay, go ahead and finish out writing the expansion this way before we give our final answer. And again, once you've gotten some practice with this, you won't have to necessarily show this whole thing if you don't want to. If you can figure out these coefficients using Pascal's triangle or your combinations on your calculator without writing it down, that's fine. But just for right now, finish writing it out, get some practice. All right, did we all get that up there for your expansion? Okay. Then the last thing that you would have to do, if this was the question on the test or the quiz, is to at least give me what is the coefficient. Okay, so like what is the 4 to the 0, or sorry, not 4 to the 0, but 4 choose 0, 4 choose 1, 4 choose 2, 4 choose 3, and 4 choose 4. And then simplify your any 0 exponent problems. So you can either plug those in the calculator, or we can use Pascal's triangle, the fourth row of Pascal's triangle, to figure out what the coefficients are. So what would my coefficient be for 4 choose 0? 1. The first one is always 1, and the last one is always 1. So I've got 1 times a to the 4th, and then this negative b over 2 to the 0 goes away. What is my second coefficient? 4 times a to the 3rd, and negative b over 2. 4 choose 2. 6 times a squared, and negative b over 2 squared. 4 choose 3. 4 again. A to the first power, and negative b over 2 to the third power. And then 4 choose 4 would give me 1. A to the 0, so I don't need to write that one, but I do need to write negative b over 2 to the fourth power. Okay, if this is a test quiz question, you could leave it like this. There might be a spot where it's a multiple choice question, and we need to rearrange it so that my number is only before my variables. Okay, so like if this was a question, that would be fine to leave it like this, but we can also simplify this a little bit so it looks a little nicer, right? Because I can go ahead and take this 2 out front. I could take this 2 squared out front. And so we're going to simplify it like that together here so you guys can see an example of that. So 1a to the 4th is obviously not going to change, so I've just got 1a to the 4th. Now, when I'm simplifying this, I like to think about, like, this whole thing is just multiplication, right? So I could write it like 4a cubed times a negative b, but I'm going to put the negative out front just because it's a little nicer that way. And then divided by what's in the denominator there? A 2, right? Now, could I simplify that fraction? Yeah, I could simplify that fraction to give me negative 2a cubed times b. Okay, I'll do one more with you, and then I'm going to let you simplify the rest. So if I multiply this second one here together, I would get... Careful with the exponents, because this time I'm going to have 6a squared. It's still negative. All of them are going to be negative, right? But then it's b to what power? B to the second. And then in the denominator, it's not just 2 this time, it's 4. So I could simplify this answer to be negative 3/2 a squared b squared. See how it just looks a little bit cleaner writing it like that instead of having all of your fractions and your parentheses and your squared things? It just makes it a little cleaner. Okay, so go ahead and try finishing out the last 2, rewriting them so that your coefficient is where your number is. Yeah, so slight mistake here. This should be a positive because I'm squaring, I am squaring a negative. So a negative times a negative is a positive. But then is my cubed term going to be positive or negative for that one? Negative. It would be negative for that one. Okay. So if I simplify this one, I get negative, it's what, 4 over 8 technically, and then it could be simplified. So a to the first and b to the third. Or I could rewrite this as 1/2, right? And then the last one, a negative to the 4th power would be positive, and then it would be b squared, or sorry, b to the 4th power with a 1 over, not 8 actually, but 16 in front of it. Yeah? So again, this might be like a multiple choice question where the answer that is shown is this, and it's not what we originally got, okay? So that's like when you would have to for sure simplify it. If it just said to expand it, I'm okay with you leaving it right here as this answer, okay? All right, last example is if we are finding a specific term in the binomial expansion. Say I had like 172 power, and I wanted to figure out what the 100th term was. Instead of having to write it out and find what the 100th term is, there is obviously another formula that we can use to figure out quicker what is the 100th term of that sequence. So the formula is very similar. This is also on your gold sheet. If you want to write something next to this saying that it's the nth term of your binomial expansion, or find a specific term, something like that, so you know what that formula means, it's somewhere on the top of the back page of that, so that you know, like, what is that formula? How do I use it? Okay? You could say gives you a specific term, something like that. Okay, so in this case, I've got a plus 2b to the 10th power, and I want to find the 4th term, okay? So my n value for my exponent, n is going to equal 10, but I want the 4th term. So in terms of this formula, what value or what letter is going to be 4? R. It says the rth term, so r is equal to 4. And now we're just going to plug in the information into that formula, okay? So I've got 10 choose 4 minus 1. I'm going to write it exactly like the formula is, and then we'll simplify it. Then I've got x. What is my x in this example? My x is a. Okay, so it's going to be a to the n, which is 10, minus parentheses r minus 1. So 4 minus 1. Just following that formula. And then what is my y in this case? 2b. Okay, so in parentheses, I've got 2b, and that is raised to the r minus 1, or 4 minus 1 power. Now from here, can we do some simplifying? Yes, so I've got 10 choose 3 times a to the, what is that going to be? 10 minus 3, so that's 7 power. And then times 2b to the 3rd power. So 10 choose 3, what's that? Plug that in your calculator, what do you get? Well, if we really wanted to, you could look on the 10th row of Pascal's triangle in the 3rd position. It would give you that number. $120. So 120 times a to the 7th times 2b to the 3rd. Now, if I wanted to fully simplify this, could I do some more? Yeah, I could rewrite this again. 120a to the 7th. What would this simplify to be? 2b to the 3rd power. 8b to the 3rd power. Which I could simplify one more time for my final answer of 120 times 8, which is 960, a to the 7th and b to the 3rd. So that is the 4th term in my expansion of this binomial to the power of 10. Okay? That is it. Okay? There is homework on Schoology. Homework on Schoology. Most of the classes finish it within, class time, last period, so I think you guys should probably be in the same boat. If you have any missing work for this unit, this would be a great time to work on that as well.